Welcome to Brain Vision.
So, in order to make an ammeter, a shunt resistor should be placed in parallel with the galvanometer. This means that the voltage across the shunt resistor should be equal to the voltage across the galvanometer since both of them are connected in parallel now. This implies, so for the shunt resistor, we have the net current flowing to be I full minus I through the galvanometer times R of shunt, and Vg is IgRg. So let me just draw a rough diagram to give you an idea of uh, what is happening over here. So in order to make an ammeter, there should be a shunt resistor with resistance, let's say R of shunt that we wrote here. So this should be connected in parallel with the galvanometer. Let's say that galvanometer has resistance Rg. And this is the total current, which is I full. Now that these two are parallelly connected, so the current gets divided into these two branches. So if this is Ig, the current in this branch will be I full minus Ig. This is the net current after the current goes through this branch. So this is the leftover current. So this should be the total current I full minus current through the galvanometer. So now the voltage across these 2 points are equal because they are connected in parallel. Now the voltage across this galvanometer is Ig times Rg by Ohm's law, and again by Ohm's law the voltage across the shunt resistor is current flowing through this, which is I full minus Ig times the resistance R shunt. Now from this relation we can find the shunt resistance, which is equal to Ig Rg over I full minus Ig. And we are given the current through the galvanometer being 55 times 10 to the power minus 6 ampere. The resistance of the galvanometer is 32 ohms. Total current is 25 ampere. Now, solving this expression, we get the shunt resistance to be 7 times 10 to the power minus 5 ohms. For the second part, we have to make a voltmeter. So for this case, the resistor should be connected or placed in series with the galvanometer. So if this is the resistor, say series resistor, so that should be connected in parallel with the galvanometer. So these two resistances are in series. Now, since these are connected in series, the current flowing through the series is equal to the current flowing through the galvanometer because it's basically the same current that's flowing through both of them. So let's call that current to be Ig because Ig is the current passing through the galvanometer, which we know, and the total current is equal to Ig now. Now, the voltage across these 2 points So let's find the equivalent resistance first for this part. So for this part, let's find the equivalent resistance. So since these two are connected in series, the equivalent resistance will be sum of both. And by Ohm's law, voltage across these 2 points, the red dots, so let's call it voltage full scale. So this will be equal to the current flowing through this, which is Ig now, times the equivalent resistance, which is I series plus Rg. From here we can find the series resistance that's connected with the galvanometer. So that comes out to be the voltage across these 2 points, like as shown by the red dots, over Ig or I total minus Rg. So the voltage is 250 volt. Current through the galvanometer is the same as the total current, and that is also given. And the resistance of the galvanometer is this. So we solve that and we find the series resistance to be equal to 4.5 times 10 to the power 6 ohms. So in the first part we solved, a we made an ammeter, and in the second part we made a galvanometer. So let me just, yeah. Now I think this is 32, which I wrote 30 by mistake. So